Good afternoon and thank you. I'm Luis Avastano and I'm going to be talking today about Vortex catheter technology, a new platform for mechanical thrombectomy in stroke. As you may know, stroke is a bad problem. Every year in America, more than 200,000 patients have what we call a large vessel occlusion, which is a very disabling disease. The majority are going to die or be discharged to a nursing home. In 2015, 4 years ago, there was a breakthrough in the way we treat these patients. We know that if we are able to go up into the brain with stents or suction catheters, or generally both, and we can pull the clot out, patients are going to do better. And we have helped a lot of patients since 2015. The market is flourishing, the indications are expanding, although there are several problems with the technologies that we use right now. First of all, we only achieve complete recanalization in less than 50% of patients, despite our best effort. And we try it multiple times with multiple devices to get there. And even in the best case scenarios, it takes, in average, 40 minutes or even longer. And keep in mind that time is important when you have a stroke. Every second counts. And even in the best case scenario, where we achieve to reopen, 1/3 of the patients are going to do very poorly, die or being disabled. So we wanted to develop a technology that could address all these problems with a single device. And we developed Vortex catheter technology, which is based in a proprietary mechanism to develop a whirlpool, a powerful whirlpool within a catheter that drives a microcatheter inside the catheter, or shaft as we call it. And the shaft is hollow, so we can advance the shaft within a wire. So now we have a telescope system that can be self-delivered to the brain, and at the same time can be activated to generate a vortex to remove the clot. We can achieve complete recanalization in 80% on a single attempt with embolization, and we propose a 1-minute thrombectomy. And this is a video to show you. There is a clot that is engaged by vacuum. It's too fibrotic to be removed, so you activate the vortex, and that's what happens. And then you can see how the catheter is being twisted 3 times, and the vortex still works, and even 4 times, and that works. So basically, this technology allows the removal of clots, which cannot be removed with our technology. But that's not enough. We have to do it within a minute. That's the proposition. So you can see here, this is a realistic anatomy of the human cerebral arteries. You can see how the wire is being navigated, and that allows the advancement of the shaft over. And the wire plus the shaft has enough body, has enough structure to push the suction catheter over. As you can see in the top left, there is a clock. Okay, so we are less than 30 seconds so far. Then we turn on the vacuum, and as I said, these clots are too fibrotic. It's not coming out. So at this point, you turn on the vortex. And without embolization, the clot comes out. So 1-minute thrombectomy. So right now, we are transforming a research prototype into a clinical prototype, and basically a minimal viable product. We have 3 submitted patents, including a PCT, and the anticipated regulatory classification for a thrombectomy device is a class 2, likely de novo, although we would like to work with a regulatory agent to better define that. This is what we plan to do in the next 18 months. Number 1, the company was recently funded. It's going to be here in Boston, and there is a great talent here in the Boston ecosystem, and we want to recruit that kind of talent. We need to do a fundraise. We need to do a pre-submission meeting with the FDA. And then, of course, advance the design control of the development and do first in human late next year. Thank you.
Thank you for your presentation. I'm trained as a mechanical engineer, and it's really cool, technology. So my question was, so I read the speed of the, this catheter rotation, which is pretty high, 100,000 RPM. I'm just wondering, what would be your strategy to show the safety of this technology?
Yeah, that's a great question. We have done extensive preclinical work so far. We have used a dynamometer to quantify what is the force that the catheter is transmitted to the vessel, and it's 2 newtons per meter. Just to give you a comparison, is 150 times less than a balloon angioplasty, which we open in the arteries to dilate. Then we have done animal tests where we don't see histological damage or dissections. we have harvested several human brains at the morgue, and we have showed that we can introduce clots, which are analogs histologically the same and mechanically tensile stress the same than the clots that we remove in patients. And we remove them with the technology, and we do not see any evidence of vessel damage. And we have even done basically whole head and neck mechanical thrombectomies, human cadavers, and we see that we can remove the clot without causing dissection or damage, angiographical damage or histological damage. Thank you.
Thank you.